Morning students. Already in my previous session I completed three major properties of the D block elements. Now we are going to start another important property, that is called color property. Actually, my dear students, most of the transitional metal ions exhibited color property. This is due to three reasons. In chemistry laboratory, different kind of the salts are there. For example, copper sulfate, it's a blue color compound, and K2Cr2O7 and orange color compound. So different type of the compounds has colorful. What is the reason why especially transitional metals ions are exhibited the color? What is the reason? The information we will discuss in this class. So my dear students, see here, the color properties, this is the due to three reasons. Number one reason is the unpaired electrons present in the d orbital. So how the unpaired electrons are decided color behavior in a transitional metal ions, later we will discuss. So what are the three reasons? Number one reason is unpaired electrons present in the d orbital, definitely that compound existed color. And second one is based on nature of the ligands. So ligand is also very important, especially this words is coming in the complex compounds, complex coordination compounds. And third one is the dd transition. Dd transition is nothing but d orbital electrons are transition from the higher energy level to the lower energy level, or lower energy level to the higher energy level. So these three reasons are very important. If any one of the transitional metal ion can be existed, the major three reasons is unpaired electrons in the d orbital, second one is the based on the nature of the ligands, third one is the dd transition. So the first reason, unpaired electron in their d orbital. See carefully, Fe plus 2, Fe plus 3. For example, iron loses 2 electrons, and here iron loses 3 electrons. This name is ferrous ion. Fe plus 2 is commonly known as ferrous ion because of same element can exist a different kind of oxidation state. Least oxidation state of the ion is always us, OUS, us sound is coming. So that's why it's a ferrous ion. Higher oxidation state of the elements is always IC. So ferric ion. So this is a ferrous ion and ferric ion. So now see here, Fe plus 2, listen carefully, iron atomic number 26, this is a configuration 4s2 3d6, 4s2 3d6. Here already 2 electrons loses. 2 electron loses means the 2 electron from the last orbit. 2 electron from the last orbit. Apo argon 3d6 4s0. So Fe plus 2 electronic configuration, argon 3d6 4s0. It means 4 unpaired electrons are there. Listen carefully my dear students, 4 unpaired electron. If the 4 unpaired electrons, it means iron loses 2 electron in any compound. Iron loses 2 electron in any compound, generally they are existing green color. For example, see here, FeSO4, sulfate oxidation state -2, iron oxidation state +2. That's why ferrous sulfate is what is the color? Green color, because of in this compound, this is the transitional metal compound. In this transitional metal compound, transitional metal is the iron. Here 2 electrons are loses. 2 electrons are loses means 4 unpaired electrons are there. 4 unpaired electron means the entire the compound existed green color. It's a clear ma? Next, in case of Fe plus 3, ferric ion. So ferric ion means 3 electrons are loses. 2 electron from the 4s orbital, 1 more electron from the d orbital. That's why here final configuration of the ferric ion 3d5 4s0. 3d5 means 5 unpaired electron. 5 unpaired electrons means is the decided the color is yellow color. So for example, FeCl3. See here another example, FeCl3. You know the my dear students, each chlorine required 1 electron. That means here how many chlorines are there? 3 chlorines. So 3 chlorines means 3 electrons are accepted from the ion. So that's why this iron metal ion existed +3 oxidation state. If iron to show +2 oxidation state, they are showing the green color, +3 oxidation state, they are showing the yellow color. So most important point my dear students, if unpaired electrons present in the d orbital, they are showing the color property. So now question is how, if the any one of the compound in the d orbital has unpaired electron, how they are decided the color, how they are form the color. Now we will be explain. Some examples are there here. See, Cr2O7 minus 2 orange color, K2Cr2O7. If K2Cr2O7, MnO4, KMnO4 pink color, KCrO4 yellow color. So these are important examples, my dear students. Now we are going to discussing if any one of the transitional metal compound existed unpaired electrons in the d orbital, how they are showing the color property. First we will discuss this tabular form. Titanium plus 3. Titanium means if any one of the transitional metal compound titanium, it can lose the 3 electron, the color is a purple color. Vanadium plus 4 means blue color. Vanadium 3 plus means green color. Vanadium loses 2 electron, commonly violet color. Chromium also loses 3 electron, it's commonly violet color. Mn 3 plus means violet color. Iron plus 3 yellow color, ferric ion. Fe plus 2 green. Cobalt plus 3, cobalt plus 2. This is a cobalt plus 3, cobalt plus 2, blue and pink color. Nickel plus 2, green color. Copper 2 plus, blue color. Chromium plus 2, blue color. This is the most important area, especially in the NEET level. Now see, my dear students, if any one of the transitional metal compounds having unpaired electron in the d orbital, how they are showing the color property. So see, for example, I will take one example, titanium tetrachloride. Listen carefully. Titanium tetrachloride. See what happened in the titanium, this is one compound. In the titanium tetrachloride, chlorine is the electronegative element. 3 electrons are accepted from the titanium. So that's why here minus 3. Now here minus 3 oxidation state, here plus 3 oxidation state. It means if loses 3 electron to chlorine, here unpaired electrons are there. In this compound, entire this compound, unpaired electrons are there. In this compound, unpaired electron means what happened here? The sunlight absorb this compound. In the d orbital, electrons are existed from the lower energy level to higher energy level. So the electrons are jump from the lower energy level to higher energy level. They are immediately to come back to their original position. So come back to original position means energy is emitted. That emitted energy is converted into color. This is the most important point, my dear students. See, once again I explain here. Titanium tetrachloride, generally seen in a titanium tetrachloride. Now here 3 electrons. From the titanium, 3 electrons are jumping to the chlorine. So NiH in the d orbital 1, 2, 3, 4, 5. D orbital, how many unpaired electrons are there? Titanium loses means, for example, titanium 3 electrons are losing. What is the atomic number of titanium? Scandium, titanium. So calcium, scandium, titanium. Titanium is 22. General electronic configuration is seen in here. Titanium 22. General electronic configuration. Argon 4s2 3d2. Argon 4s2 3d2. 22. Scandium, titanium. Upon 3 electrons loses means what happened here? 2 electron from the s orbital, 1 electron from the d orbital. Upon configuration titanium plus 3 configuration is argon 3d1. So one unpaired electron is there. This one paired electron means what happened? One unpaired electron present in the titanium plus 3. Upon NiH, the sunlight fall down on the particular substance or particular compound. These electrons are jumping to higher energy level. So again you immediately reback to the original position. So the electron DD transition is there. Electron transition is there. Upon NiH, the emitted energy is converted into the color. This is the reason if any one of the d orbital has unpaired electron, how they are existing the color. This is the reason. So my dear students, is the most important point. Here one note is there, clearly observe. transitional metals ions which do not have any unpaired electron in their d orbital. They do not have any unpaired electron in the d orbital. Either 0 electrons or 10 electrons does not exhibited any color. That is the most important point, my dear students. So in the d orbital, showing 0 electrons or 10 electrons, that kind of the compound never exhibited any type of color. This is the most important point, my dear student. For example, see here, scandium plus 3. Scandium plus 3, argon 3d0. 3d0 means if any one of the compound has scandium is there, and that particular compound scandium showing the plus 3 oxidation state, definitely that compound is a colorless compound. Even copper plus 1. Copper plus 1 also, because of d orbital completely filled with electrons. So copper plus 1, scandium plus 3, titanium plus 4, zinc plus 2. So this kind of oxidation state, the compound does not show any kind of the color because of d orbital 0 electrons or 10 electron. 10 electrons means here completely paired. Completely paired means transition is not there. Electron transition is not possible. Even 0 electrons mean there is no any unpaired electron. That's why those compound cannot be existed any color. So scandium plus 3, copper plus 1, titanium plus 4, zinc plus 2 cannot show any kind of the color. And one more note, my dear students, here. Second B in the transitional elements or D block element, second B, zinc, cadmium, mercury, generally their common oxidation state is the plus 2. Zinc plus 2, cadmium plus 2 and mercury plus 2. So here plus 2 means from the s orbital they are easily to lose the electron. Upon and the d orbital completely 10 electrons are there. So that's why second B compounds, if second B compounds cannot existed any color, cannot no color in case of Zn plus 2, cadmium plus 2, mercury plus 2. Understood, my dear students? See, here one question is there, carefully observe. Copper sulfate, CuSO4 is a color compound. Listen, Anna. CuSO4 is a color compound, whereas zinc sulfate is a colorless compound. What is the reason? Why? See, copper sulfate. Copper sulfate, CuSO4. It means sulfate oxidation state minus 2. So sulfate oxidation state minus 2 means copper showing the plus 2 oxidation state. So Cu plus 2 oxidation state, actually copper electronic configuration, argon 4s1 3d10. But here Cu plus 2. Cu plus 2, argon, from the s orbital 1 electron is removed, from the d orbital 1 electron is removed. So that's why in Cu plus 2, 4s0 3d9. 4s0 3d9 means how many unpaired electrons are there? 1 unpaired electrons are there. If the 1 unpaired electron means, definitely they are showing the color property. What kind of color property? Blue color property. But in case of ZnSO4, here sulfate same sulfate minus 2. So here zinc loses 2 electron. So Zn plus 2 means actually electronic configuration of the zinc, argon 4s2 3d10. So now 2 electrons are removed from the 4s orbital. Now what happened? Argon 3d10 4s0. 3d10 means completely filled electrons in the d orbital. So there is no any unpaired electron. That's why zinc sulfate cannot existed any color. This is the most important point, my dear students. So ultimately I already discussed 3 reasons. Number 1 reason is that if any one of the transitional metal compound has unpaired electron, that compound definitely to existed color property. And second one is the nature of the ligands. And third one is the DD transition. It's the most important, my dear students. Already completed first reason. What is the first reason? First reason is the unpaired electron present in the d orbital. Definitely that kind of the compound show color property. Already what is the reason? How any one of the compound has unpaired electrons in the d orbital, how they are showing the color property, I am clearly be explaining here. The next one is the based on nature of ligands. This is the most important word, especially in the complex compounds category. What is a ligand? See carefully. Which is having ability to donate one pair of electron to the central metal atom is known as ligand. So for example, this is a central metal atom. this is one compound. This compound has one lone pair of electron. The ability to donate one lone pair of electron to the central metal ion, cation or central metal ion, that's this compound name is the ligand. So ligand is nothing but it can easily to donated the lone pair, one pair of the electron to central metal atom, that is called ligand. So my dear students, generally complex compounds also showing the color property due to the reason is a ligand behavior. See Nana, metal atoms plus ligands is commonly known as coordination complex compound. Metal atoms plus ligands are there, commonly known as the complex coordination complex. So now here this is one of the hexa aqua copper plus 2 generally. So here copper, this is a ligand. So because of this is central atom, this is a ligand, this is donated to electron here upon NH. So copper connected with water, light blue color is formed. So now same compound but ligand is different here. Ligand is different means thick blue color is formed. So that's why my dear students, very important point, in complex compounds or coordination compounds, the color properties is decided by the ligands. So why here introduce the complex compound means all type of complex compounds only formed by the D transitional elements. D block transition elements only existed the coordination compounds are nothing but complex compounds. So now here copper H2O is taken 6 times plus 2. Again you will reacted with HCl solution, CuCl4. Now the color is a green color. So my dear student, it's a simple information. If any one of the coordination compound showing the color property is based on the nature of the ligands, So two reasons are completed. Reason number 1, if any one of the compound has unpaired electrons present in the d orbital, that compound are definitely to exist color property or color behavior. But if any one of the compound d orbital 0 electrons or d orbital 10 electrons are there, do not exhibit any color property. And second reason is based on the nature of the ligand. If coordination compound, the ligands decided for the color property of the given coordinate compound. Understood my dear students? Okay Nana. Last and final reason of decided the color property, DD transition. DD transition means, see carefully, this is the d orbital. Listen carefully Nana. This is the d orbital. 5, it splits into 5 category: dxy, dyz, dzx, dx square, y square, dz square. For example, this d orbital present in the given compound or complex, given any one of the compound, and then what happened, the sunlight is, listen carefully, this d orbital has unpaired electron, maybe unpaired electron. The sunlight is absorb this compound. The sunlight is absorb this compound. Immediately in the d orbital splits into two level. So that is called number 1. First 3 1 is the T2G level. T2G level means triple degenerated orbital. So first 3 1 dxy, dyz, dzx is the triple 2 generated orbital, and last two energy degenerated means equal energy. So dx square, y square, dz square. So this is the EG level orbital, T2G level orbital. Now my dear students, DD transition is present in the any compound. That compound is definitely show the color property. For example, what is the DD transition? Here maybe 3 electrons, unpaired electrons are there. These unpaired electrons present in the compound. One compound has d orbital, 3 unpaired electron. If sunlight fall down on the particular compound, immediately these electrons are jumping from the T2G level to EG level. After that, immediately to come back from the higher energy level to the lower energy level. If the electrons are jumping from the higher energy level to the lower energy level, now energy is emitted. The emitted energy is converted into the color. So ultimately, my dear students, listen carefully. If any one of the compound DD transition means if sunlight fall down on the particular compound, immediately inside of the d orbital unpaired electron, they are split into the two level. Number one, easy level, this is a higher energy level. Number two to the T2G level, triple 2 generated level, this is a lower energy level. So in this between easy level to T2G level, electron transition is there, definitely that compound show the color property. Understood, my dear students? So DD transition means if any one of the compound has unpaired electrons in the d orbital, after receive the sunlight, the unpaired electrons are split into the two levels, that is called EG level and T2G level. So here the electrons transmission is possible, electron DD transition is possible. This is the d orbital, this is the d orbital. DD transition is possible means definitely that compound can existed color property. Listen, my dear student, if strong ligand has more splitting, if any one of the complex compound ligand is very strong, the splitting is maximum, and if weak ligand has low splitting, so low splitting means color behavior intensity also decreases, high splitting means color intensity is also increases. So my dear student, third reason is if any one of the compound DD transition is present here, that compound definitely to existed the color. So three reasons, my dear student. Number one reason is the unpaired electrons in the d orbital, definitely that those compounds are existed color. Second one, nature of the ligand, especially in coordination compound, ligands also decided the color property. Third one is DD transition is present in any compound, definitely color properties is there. DD transition is not there means there is no any color property, because of the d orbitals, this d orbital completely filled 10 electrons, completely filled the all pairs mean DD transition is not possible, because of there is no empty orbital, DD transition is not possible. Understood, my dear students? This is a DD transition. One more note here there, DD transition is present in any compound, that compound show the color property. DD transition is not there, color property is not exhibited. This is the most important point. Next, after that, some examples. See here, zinc sulfate colorless compound, already discussed this example. Zinc sulfate, because of 3D 4s0, 3d10 4s0, because of normal zinc electronic configuration, argon 4s2 3d10. Here zinc 2 plus means 2 electron loses from the 4s orbital. So now here the entire the d orbital completely filled electron, so no DD transition due to the completely filled d orbital, so it's not exhibited any color. That is the reason zinc sulfate cannot show any color. It's mean, my dear student, white color, zinc sulfate is a white color. White is not a color in chemistry point of view, it's a colorless compound. Next, another example, copper sulfate. So copper plus 2, sulfate 2 minus. Now what happened here, copper plus 2 means 3d9 4s0, because of one electron from the s orbital, one more electron from the 3d orbital. Upon 9 electrons are there. 9 electrons means what happened here? One unpaired electrons. Where is located one unpaired electrons? In a higher energy level, EG level, one unpaired electron. If absorb the sunlight, if one unpaired electron means if absorb this compound, copper sulfate absorb the or receive the sunlight energy, immediately these electrons are transition down to back, immediately down and immediately back. Transition is possible. Transition means DD transition is possible means here, my dear students, important point is here one electron coming from the higher energy level to lower energy level, one more pair from the pair electron jump to higher energy level. So this unpaired electron join to here. This is called transition. In this way, in this process, energy is emitted energy is converted into the color. That is the most important point. Here already paired. Pair means if this electron is coming from the higher energy level to lower energy level, here down one pair electron is again one electron is jumping to the higher energy. This is transition is continuously going on. So that's why, my dear students, if any one of the d orbital electron transition is possible, definitely that compound show the color property. So here see Nana, observed color, emitted color. Actually every compound has, you will see green color. See, observed color, one color is there, Emitted color, one more color is there. If the green color is absorbed means from the sunlight. If the green color is absorbed from the sunlight, pink color is emitted. If yellow color is absorbed from the sunlight, blue color is emitted. So blue and green color means red color is emitted. So this is the important area. Next scenario. One more point. The transitional metals ions absorb a part of visible region of a light and emit a rest of the 6 colors. So actually a transitional metal ion absorb a part of visible region from the sunlight and emitted rest of the 6 colors. So absorb the sunlight, emitted colors. So the color of the metal ion is the color of the emitted light. That is the most important. What color is emitted from the compound, that is decided for the compound color. The color of the metal ion is the color of the emitted light. So here 6 colors, complementary colors can be identified by the using Munsell color wheel. Violet, blue, green, yellow, orange and red color. These 6 colors are emitted. So KMnO4 is the color is dark pink color. K2Cr2O7 is the orange color. And most important question is which one of the ions show color property? Already said zinc +2 no color, mercury +2 no color, cadmium +2 no color, because of zinc ion, mercury ion, cadmium ion completely filled 10 electrons in the d orbital. See 3d10, 5d10, 4d10. So this 3 compound never existed any color property. But manganese 2+ means 3d5, 5 unpaired electron means definitely it is a color property. And one more question, my dear students, see here, which of the following compound is a colored? JEE 2009 question, which of the following compound is a colored? Titanium tetrachloride, ferric trichloride or FeCl3, COCl all. So now he will check it out. How the checked out? Titanium tetrachloride. So Cl3, each chlorine required 1 electron. So -3 means here +3. So titanium showing the +3. Titanium showing the +3 means how many unpaired electron? Only 1 unpaired electrons are there. 1 unpaired electron means titanium tetrachloride. Already seen, Anna? If the tabular form, titanium purple color. So here what is the color compound? This compound is titanium tetrachloride is a purple color. Purple color. And FeCl3. So definitely 1 unpaired electron is there, has color compound. FeCl3 also. FeCl3 is also already discussed in first FeCl3. See here Fe+3. Fe+3 means what is the color? Yellow color. So here yellow color compound. So because of here also unpaired electron, 5 unpaired electron, this is also color compound. COCl2. Cl2 means -2 +2. Here also 3 unpaired electrons are there. So my dear students, this is also unpaired electron, this is also unpaired electrons are there. Even this compound also unpaired electrons are there. That's why this 3 compound has unpaired electron. Definitely these compounds are existed color behavior. So option is all. This is the most important area, Nana. Next one. Okay, Nana. So this is the color properties of entire the transitional element. Once again recall of from the starting to what is the reason? The color properties is decided by 3 reasons. First reason is the unpaired electron present in the d orbital. Second one is based on the nature of the ligands, and third one is the DD transition. This is the most important color properties. See, Nana, one common point, even variable oxidation state, magnetic behavior, color properties, formation of complex compound and formation of alloys, interstitial compounds. So these all properties similar reason is the unpaired electrons in the d orbital. For example, any in CBSE board level point of view, one question, why a transitional metals ion can show color property? Simply you will write one answer. Unpaired electrons are present in the d orbital, that compounds are showing color property. One more question, why transitional metal ions are showing the magnetic behavior? Same answer, unpaired electrons are present in the d orbital. So this is a similar answer for all kind of the property. For example, why d block elements show variable oxidation state? Reason, unpaired electrons present in the d orbital. Why d block elements show color property? Reason, d orbitals are unpaired electrons. So this is a common statement for all properties. That's why you don't forget, my dear students. Whenever you don't know the answer in particular question in this chapter, for example, why d block elements show alloys compounds, alloys mixer compound means simple reason is the unpaired electrons are present in the d orbital. It's a clear, my dear students. So 4 properties are completed. The tomorrow class, next class we will start one more property, that is formation of alloys and interstitial compounds, complex compounds. After that, the d block elements are completed. Later we will start the new chapter that is called f block elements. Okay, Nana?